Hello and welcome back to MCAT Grind. We have Physics, Chapter 9 about atomic and nuclear. So, atomic and nuclear pertains to about 10% of all the physics questions, which may include like 3 questions in total. And this, the first function you should know is energy equals h times frequency. Now, you may see this in a different form, h times c over the wavelength, and that's because of the equation c, speed of light, equals frequency times the wavelength. That's how it's derived. Now h is a Planck's constant, 6.6 times 10 to the negative 34 joules per second, and that can be used to derive this equation, the photoelectric effect. The photoelectric effect is when an energy or a beam of light is shined at a metal. It will result in the emission of an electron or electrons at a certain kinetic energy and at a certain speed and velocity as well. Now, the metal is going to take in a certain amount of energy from it as well as you can think of it as a toll, and the frequency which you need to minimally eject the electron is by the frequency threshold. If the frequency of the photon emitted or shining onto the metal is greater than the threshold, then there will be a kinetic energy emitted from the electron. Now we can use this equation. K max, the kinetic energy, maximum kinetic energy, equals the HF, this energy, minus the work function. The work function is what the metal takes in. So, for example, you have a certain HF that is less than the work function, then this will be less than 0. You won't get a kinetic energy to emit electron, and it just won't happen. Now, what the next concept is strong nuclear force. Strong nuclear force is when a nucleus is formed from proton and neutrons coming together, and protons coming together will have molecular pushing away from each other, right? Because they're the same charge. So there's a strong nuclear force to try to pull them together to form the nucleus, because the energy, it's an exothermic process. So that binding energy that comes off of it is done by E equals mc squared, described as so. So individually, they may have, let's say, a mass of 1, 1, 1, 1. Altogether, you should say 4, right? But the actual mass of this is like 3.999. And that mass differential is because some energy is emitted as either thermal energy or some kind of energy, but that binding energy is released, equal to this equation. So mass, that differential, times speed of light squared. This is Einstein's basically explanation for that mass differential. We also have the weak nuclear force, which keeps them together, bonded together. Otherwise, they would just shoot apart. So aside from these two forces, we also have gravitational force as another major force. Electron capture is conducted by... let's start about fusion. So when we have fusion, we mean we have 4 smaller atoms or smaller compounds coming together to make a bigger one. In this case, nuclear fusion happens when mostly in the sun, right? They have the hydrogen atoms coming together to form helium, and that produces their own energy. There's a very few fusion power plants around the world, and those are conducted using hydrogen plus lithium. Fission is opposite. You have a bigger molecule and you break it down to smaller, and that eventually gives out energy in like a chain reaction form. So uranium-235 usually is broken down into 2 parts, into like smaller atoms, and also gives off energy. Alpha decay happens when it decays into an alpha particle plus another identity of atom. Alpha particle has a total molecular mass of 4 and atomic number of 2. So you can think about if I have here a certain element, it's going to subtract 4 from the total mass and subtract 2 from the atomic number. And that's going to give a new identity for it, plus this alpha particle. Beta particle is similar. It gives off another particle, but instead you give off a beta particle, which here is -1 of atomic number. So your atomic number actually goes up in a new element. Gamma gives off a 0, 0, which means that there's 0 change in the atomic mass as well as 0 change in atomic number, but you must start off with a loaded one, a higher energy state atom. Electron capture is the opposite of beta decay. You capture an electron, and that's going to just -1 atomic number. Half-life happens when you multiply start with starting molecule, and the substance, every time you multiply, goes through a half-life of a certain number, arbitrary number of the substance. It's going to decrease it by half. So let's say the half-life of this pen is 50 years. So within 50 years, it's going to degrade itself by 50%. So 50 years is the half-life. So 100 years will be 2 half-life away, right? So it will be half and a half. So 1/4 of it will be left. So number of half-life, so number of years divided by the years of half-life, you get an n, and you multiply the original substance by half n. Exponential decay is one of the more confusing ones because there's ln 2 involved. Ln 2, you will see shortly, comes out to be about 0.7. So that can help make calculations easier. So 0.7 times t, which is like the time, divided by the half-life, and then negative over that. It should help solve it a lot easier. Okay, and that's pretty much it.